Hey everyone, you've probably seen this Apple commercial with Bella Ramsey asking Siri a really complex question. She wants to know the name of someone she met months ago at a specific cafe. This was aired during the iPhone 16 launch, and yet this feature has been delivered yet. This seems impossible, right? Well, today I'm going to show you exactly how systems like this can actually work. Let's explore the science behind building intelligent agents that can handle complex multi-step queries.
So what we're really talking about here is LangGraph ReAct agents and supervisor architecture. Now I know that sounds like a mouthful, but trust me, by the end of this, you'll see how these concepts come together to create AI systems that can actually think through problems step by step, just like we do. Now, before we jump into the deep end, let me give you the game plan. We're going to start with the basics, what most AI agents look like today, and why they're, well, let's just say they're not quite ready for Bella's question. Then I'll show you how ReAct agents change the game completely by actually thinking through problems. After that, we'll see what happens when you get multiple smart agents working together under a supervisor. It's like watching a really efficient team in action. And finally, we'll bring it all back to that Siri moment and see how this stuff works in the real world. All right, so let's start with what most AI agents look like today. I'm assuming most of you know what LLMs are and what agents do, but let me steamroll through this real quick for the unversed. LLMs, large language models, are basically trained on massive amounts of data and work on probability math, predicting what the next letter or word should be. Pretty cool, right? But here's the catch, they've got some serious limitations. Let's say we trained an LLM on all the data we have up until today. And then the day after tomorrow, we ask it what happened yesterday. It's completely clueless. The training data cutoff was today, so it has no idea about anything that happened after that. Heck, it doesn't even know what date it is right now. That's where agents come in. They basically give wings to LLMs. We can equip agents with additional data sources and tools so they can make informed decisions and actually interact with the real world. So now let's meet Bob. He's our friendly neighborhood weather bot. You ask Bob for weather, he goes, okay, let me check my weather tool, gets the data, and boom, gives you an answer. It's super straightforward. You ask, he processes, he responds. For simple stuff like, what's the weather today? Bob's your guy. He's reliable, he's fast, and he gets the job done. But here's where things get interesting, and by interesting I mean problematic. Let's throw Bob a curveball. Instead of just asking for today's weather, let's ask him check 3 days of weather, and if it's going to rain, suggest some indoor activities to plan a picnic. Watch what happens. Bob immediately goes into panic mode. He's like, I can check today's weather, but 3 days, indoor activities, what is this sorcery? The poor guy just wasn't built for this kind of multi-step thinking. He can't break down complex problems, he can't adapt his approach, and he definitely can't string together multiple actions to solve one big problem. So this is where ReAct agents come in to save the day. Now, ReAct is just a fancy way of saying reasoning plus acting, but here's what makes it cool. Instead of Bob's one-shot approach, ReAct agents actually think things through step by step, kind of like how you and I solve problems. They go through this cycle. First, they think, okay, what do I need to do here? Then they act. They actually do something about it. But here's the kicker. They don't stop there. They look at what happened, think again with this new information, and then act again. It's like having an internal conversation with themselves until they solve the whole problem. Now, I know that might sound a bit abstract, so let me show you exactly how this works under the hood. Check out this flow diagram. This is what's happening inside a ReAct agent's brain, if you will. The agent starts up, calls the model, think about what to do. The model decides, do I need tools for this or can I answer directly? If it needs tools, it uses them, gets some results back, and then, here's the magic, it goes back to thinking again, but now with all this new information. See those flowing dots? That's the agent literally cycling through this think, act loop until it's got everything sorted out. It's like watching someone solve a puzzle. They don't just slam all the pieces together at once.
They look at what they have, try a piece, see how it fits, then figure out what to try next. Okay, so now let's see what happens when we upgrade Bob to be a React agent and throw him that same complex picnic question. Watch this transformation, it's honestly pretty satisfying. Bob starts thinking, all right, this is a multi-step problem. I need weather for 3 days, then I need to check if any of those days have rain, and then I need to suggest indoor activities. Let me start with day 1. Guess the weather data, thinks again, okay, day 1 is sunny, but I still need days 2 and 3. Keeps going, finds out day 2 is rainy, thinks, aha, rain detected, now I need those indoor activities. Gets the activities, and finally puts it all together into one comprehensive answer. From confused Bob to super capable Bob. That's the power of giving an agent the ability to think through problems step by step. Pretty neat, right?
Let's add in some more complexity to this. What if we ask him to quote unquote figure out the budget for this entire picnic activity? Whoa, suddenly we're in a whole different league of complexity. Sure, we could hand Bob a research tool and say, hey, go find budgets for all these different activities and somehow stitch them together to give us an average cost per person. But honestly, that's going to overwhelm our weather focused buddy. Bob's specialized in weather stuff, not in math or budget planning. And when you push an agent way outside its comfort zone like this, things get messy. It might just start making stuff up, aka hallucinating. Now here's where things get really interesting. What if, instead of having one agent trying to be good at everything, we had a team of specialists? Meet Mia. She's our supervisor and she's basically the project manager of the AI world. Mia doesn't do the actual work herself. Instead, she's got this awesome team. Bob still handles weather because hey, he's really good at that now. Tom is our math whiz and Ved is our research guru. When a complex query comes in, Mia's job is to figure out who should handle what, coordinate all the work, and then put together the final answer. It's like having a really smart conductor directing an orchestra. So let's see Mia and her team tackle something really complex. A query that needs weather data, research, and math calculations all rolled into one. This is where the supervisor architecture really shines. User asks, check weather for the next 3 days, suggest indoor activities if it rains, and give me a budget for all this. Mia immediately goes into coordination mode. Okay, this is a 3-part job. Bob, I need you on weather duty. Ved, start researching indoor activities with pricing. Tom, you'll crunch the budget numbers once Ved gets back to us. Watch the workflow. Bob does his React magic and comes back with the 3-day forecast, including that rain on day 2. Ved jumps in, researches indoor activities and their costs. Tom takes Ved's data and calculates budget ranges and averages. Finally, Mia takes everyone's work and synthesizes it into one comprehensive response that covers weather, activities, and budget planning. It's like watching a well-oiled machine in action. Now you might be thinking, this all sounds great in theory, but does this stuff actually work in the real world? Well, let me show you something I built, the SlamPy AI Assistant. This is a production system that's actually running right now on my website, slampy.in, using exactly the supervisor plus React agent architecture. The SlamPy AI Assistant team has a supervisor that routes different types of queries to specialized agents. I have put in 3 agents, front desk agent, communications manager, and a math professor just for the sake of this demo. Why math? Well, math is fun, isn't it? Someone asks about company services, that goes to the front desk agent. Want to get in touch? That's the communications manager's territory. Need some calculations done? Math professor to the rescue. Here's a real example. Someone wants to contact SlamPy about an AI project. The supervisor routes this to the comms manager, who then goes through the React cycle, thinks, I need their email to submit the contact form, asks for it, gets the email, uses the contact form tool, and confirms submission. Real system, real results. All right, let's see this in action. Hop on over to slampy.in and fire up the chatbot. Now let's throw it some basic questions. Tell me about your company. Wow, check out that lightning fast response. It just spilled all the company details like it's been waiting for someone to ask. Now let's get a bit more interesting. How do I contact your team for an AI related project? And it's asking for our email address. Let's give it one and bam, done deal. Here's what's happening behind the scenes. This thing just called up an email tool, fired off a message to the team saying, hey, someone wants to chat about AI stuff. And if you gave it a legit email address, you're getting a confirmation email too. So if you're actually trying this out with a real email, keep an eye on your inbox. That's how you know it worked. It's magic. Now let's really mess with it. Tell me more about your company. And what's 2 plus 5? Two completely different tasks thrown at it at once, and boom, it just tackled both like it was nothing. Pretty slick, right? Alright, so now let's bring this full circle back to Bella's question. Remember that seemingly impossible request about finding someone she met months ago at Cafe Grenelle? Well, with everything we've learned, let's see how Siri could actually handle this as a ReAct agent. Siri would think, this is a memory retrieval problem. I need to search through Bella's calendar history. Searches calendar, gets 47 meetings, thinks way too many results. I need to filter by location. Filters for Grenelle, finds one meeting. Thinks perfect. Now I need to see who was there. Gets meeting details, finds attendees Bella and Zach Wingate. Thinks since Bella is asking about the guy, it must be Zach. Final answer, you met Zach Wingate at Cafe Grenelle on March 15th. But here's the thing, for an AI assistant like Siri to really nail this stuff, it can't just have a calendar manager. It needs a whole squad of specialized agents working together. Contact manager, album manager, apps manager, you name it. Each one's got their own expertise, but they all need to play nice together. And honestly, I think Apple would be absolutely crushing it if they went with the supervisor architecture we talked about, coupled with ReAct agents. Just imagine the possibilities when you've got all these specialized agents coordinating under one smart supervisor. And there you have it. We've just taken a journey from simple single-shot agents all the way to sophisticated multi-agent systems that can handle complex, real-world problems. We've seen how ReAct agents can think their way through multi-step challenges, how supervisors can coordinate teams of specialists, and how all of this comes together in actual production systems. The really cool thing is, this isn't some far-off future technology. This stuff is working right now, today. We are already building AI systems that can reason, coordinate, and solve problems that would have seemed impossible just a few years ago. I could talk about this stuff all day. It's just fascinating how we can make AI systems that actually think through problems like we do. Oh, and before I forget, I've thrown in some links for you guys. Got my website, that infamous Apple commercial we referenced, and the official LangGraph documentation about ReAct agents and supervisor architecture. Definitely worth checking out if you want to dive deeper into this stuff. And hey, if you've got any burning questions about this topic, just hit me up on LinkedIn. Thank you.